squaring versus the square root. Let's understand the relationship between squaring a number and taking the square root. So first, let's talk about squaring a number. So if I have 3 squared, the base is 3. The exponent tells us how many times we are multiplying the base by itself. So 3 squared is just the same as 3 times 3, which is 9. Works the same if we're dealing with 4 squared. The base is 4, the exponent is 2, so I take that base of 4, multiply it by itself just 2 times for 16, right? That's the idea of squaring a number. Well, then if we jump to square root, the square root of 9. Now this is where you kind of think about what number times itself gives me 9. And the beauty is that these two numbers have to be the same. So we know that 3 times 3 equals 9. So the square root of 9 is 3. Same thing with 16. What times itself gives me 16? Because these have to be the same, we know that 4 times 4 is 16, so the square root of 16 is 4. So when you think about the comparison or the relationship between squaring a number and the square root, you can see that 3 squared is 9, the square root of 9 is 3. So they're the inverses or the opposites of each other. And this works the same for everything. If I would talk about our example of 4, because 4 squared is 16 and the square root of 16 is 4. They undo each other. So think about 5 squared. What is 5 times 5? Well, that's 25. So that means the square root of 25 is 5. So you can see these match and the 5s match. So that's the idea of the relationship between squaring a number and a square root, is that they are inverses, or they undo each other because they're simply the opposite. The square root is what times itself gives me that number, and the square is this times this gives me a different number. All right, so that's the idea of square roots and squaring a number.